Find where the function f of x equals to x times 1 minus x raised to the power of 1/5 is increasing and where this function is decreasing. Find all local extreme values. Okay, that means let's start finding the critical points. First of all, let's define the domain. Looking at this function, we can see the quantity 1 minus x is raised to the power of 1/5. That's the odd root. Then odd root can accept all of the numbers. Domain are all of the real numbers. All real numbers. Or if we prefer, we may say x belongs to all real numbers. Okay, that's me. Let's start. To find the critical points, we need to find the domain derivative first. Okay, let's start with the derivative. Product rule. Yes, x times quantity 1 minus x raised to the 1/5. That's me. Let's start with the product rule. Derivative of x is 1 times 1 minus x to the power of 1/5 plus x times derivative of 1 minus x to the power of 1/5 is 1/5 quantity 1 minus x raised to the power of 1/5 minus 1 negative 4/5 and times negative 1 as a derivative of the inner function. Okay, let's clean this. Let's copy this. Negative I can put here, x over 5 possibly, and this. We may see the common factor. Let's factor out. Common factor is quantity 1 minus x raised to the power of lower number, which is negative 4/5. Okay, then this second quantity will only end up with that part, x over 5, and this one, it will be 1 minus x. Let me write a little bit nicer. 1 minus x raised to the power of 1. I hope we can see this, because when we will distribute back the same base, different exponents, we will add them. Yes, we will add them. Negative 4/5 plus 1 is 1/5. That's we will get back this one. But of course, we will not distribute this. We can leave it as a product. Okay, now again, this expression is 1 over 5th root of quantity 1 minus x raised to the power of 4, and this quantity is 1 minus x minus 1/5 x. Okay, then it will be minus x minus 1/5 is negative 6/5 x, and this quantity we can put the denominator. Beautiful. This is the derivative. And now, for the critical points, we have to find out where the derivative is 0. Where the derivative is 0 and where the derivative is undefined. Once we remember the definition of the critical points. Okay, let's write on the next page. Derivative is 0 if this expression is 0, correct? And this expression, is fraction, is 0. Let me put nicely the 5th power. Okay, this is 0, fraction is 0 if the numerator is 0. That means one more time, derivative is 0 if, let me see, 1 minus 6 over 5x equals to 0. Then x equals to 5, 6. I hope I did solve this equation correctly. And this belongs to the domain. That means yes. This is a critical number, and then derivative is undefined, could be also a critical point. if this expression is undefined, because that's the derivative. Fraction is undefined if the denominator equals to 0. Denominator equals to 0 if quantity 1 minus x equals to 0. X equals to 1. Also belongs to the domain. Yes, that's the critical number. Okay, that's we have two critical points. Now let's perform the first derivative test. Checking the monotonicity, where function is increasing, where function is decreasing. Let's put 5 over 6 and 1, and let's test the sign of the derivative. When we will take any value greater than 1 from that interval, greater than 1, we may actually notice denominator is always positive because it's raised to the power of 4. That means the sign of the derivative is determined by the numerator. Okay, when we substitute instead of x, big positive number, it will, the entire quantity will be negative, correct? Because it's 1 minus 6/5 times positive number. It's negative. Okay, now we have to pick a number, test value from this interval. This is relatively small interval, but we may pick 5.5 over 6. That's the easiest one. When we increase the numerator, we increase the whole number. That's when we substitute 5.5 over 6, it will be number greater than 1. 1 minus greater than 1 is negative. Okay, also negative. And then when we will take a number which is less than 5, 6, from that interval, let's pick 0. We may pick 0. 1 minus 6 over 5 times 0 is 0. 1 minus 0 is 1. Positive number. Okay, let's do positive. Okay, then we know that function is increasing, decreasing, or decreasing, not alternating. And we can nicely see, we can even see kind of like a shape of the function, increasing, attaining local maximum, decreasing, and again decreasing. The only situation is at 1 is decreasing and again decreasing. Since this is the number, the derivative is undefined and function is continuous, we will most likely have a vertical tangent. Vertical tangent. Yes. Doesn't extreme value is not happening, but it's definitely a critical point. Let me write this a little bit nicer. What we can do this way. Okay, I can draw local maximum and then something like this, horizontal. I mean vertical tangent, and this is horizontal tangent, and it's happening at here. It's a local maximum. In order to find the value, we have to substitute 5 over 6 to the original formula of the function. Okay, we can actually y. Okay. Color local maximum, and function is increasing and then is decreasing, vertical tangent, and is decreasing. That's the draft based on the first test. Extreme critical points, yes, 5 over 6 and 1. And yeah, we have the monotonicity, the increasing, decreasing intervals.